first principles, we use this big formula here. We use the formula, which is, yeah, limit as h approaches 0, 1 over h, f of x plus h minus f of x, right? We use this formula and derived everything. Now, remember, when you're deriving everything, when you say f prime x, you get an answer. That answer represents a slope function, right? So we want to devise a rule for differentiation rules. Instead of doing first principles, what's the short form, right? So remember, when you say f prime x is equal to limit as h approaches 0, limit as h approaches 0 of 1 over h, 1 over h into f of x plus h minus f of x, right? Remember, you can take the h down as well. Now, remember what this here represents. This here represents the slope or the gradient function. Slope or the gradient function. Now, whatever answer you get, and if you substitute a value there, you will get something called an instantaneous gradient, the gradient at that instant. Anyways, let us have a look at the short form of, instead of using this long formula, what is the short form? So the short form is, if we have a function y is equal to, f of x is equal to, let's say f of x is equal to a x to the power n. So it's to some power, is in power form. Make sure that it's always in power form. So to find f prime x, we can just say, we take the a value and the n value, we multiply them out. So a times n is a n, and take away 1 from the power. So you say x to the power n minus 1, and that's it. This is the basic formula for differentiation. This is the only formula that you need to know for the entire calculus course, right? And remember what this here represents. This here also represents the slope function, slope or gradient function. It's so easy, right? Now, since we are working with powers, let's look at rules of exponents. You gotta know rules of exponents. So what are rules of exponents? Rules of exponents and surds. Exponents and surds. What are the rules that you need to know for this calculus part only, right? So first, what we need to know is the exponent form, negative exponents, right? So if we have a constant over x to the power n, that basically becomes constant times x to the power negative n. Example, you bring this entire power from the bottom up. If you bring it up, is to the negative power. So you need to know that. And the second part that you need to know is for surds. So what is a surd? X to the nth root of x to the power m. And that will just be x to the power inside over outside, m over n. Okay? Now, after you know all this, then we are ready to differentiate. Now, I have about 30 examples to solve here. So by the end of this lesson, you will become a master at differentiation. Right, so let us have a look at all the differentiation that we got to do today. So I'm continuing from the last example. We did example 7 last. So see what the question is saying, differentiate each of the following, right? So we want to differentiate question 8. Let's differentiate. So we have 2x cubed plus 4x minus 7. Now, remember, instead of saying f of x equals, remember this is some function. So I want to differentiate this, so I'm going to say y prime. Okay, it means the slope function derivative, which is equals to, now what's the answer for this? We're going to say 2 times 3. So 2 times 3, take the constant, multiply by the power, and take away 1 from the power. X to the power, remember when you differentiate, the function is up there. So the function will become smaller. So it's going to become 3 minus 1 plus, remember x on its own means is x to the power 1, right? So what's 1 times 4? So you're going to say 4 times 1, x to the power 1 minus 1, right? Minus, now what's going to happen with the 7 now? There is a power next to the 7, which is x to the power 0. So you're going to say 0 times 7, that is just 0, because you're saying 0 times 7, right? And you're going to say x to the power 0 minus 1. Well, that falls away. So we learned something very important, that the derivative of a constant is equal to 0. So if y is equal to a constant, right, the derivative of a constant is always 0. Very important. So you can see from this example here, that's what we have learned. And that makes sense. I will explain why that makes sense. Why is the derivative of a constant 0? After this, let us simplify, and then I'll explain why the derivative of a constant is 0. So now we know 2 times 3 is 6, x squared plus 4, x to the power 0 we can leave out because 1 minus 1, and that's minus 0. That's it. So what's my answer? The answer is 6x squared plus 4, the derivative of this function. In other words, this is the slope function. This is my slope function. Now, let me explain why the derivative of a constant is 0. So remember, y is equal to some constant, let's just say 5, or in this case, some constant -7, right? Now, sketch the graph. Let us sketch the graph and see why the derivative is 0. So how do we sketch a graph of y equals -7? It's just basically a straight line. Guys, if you have any questions, please ask, right? So this is the x-axis and this is the y-axis. So there's 0 here. Y equals -7 is just a horizontal line, right? -7 is a horizontal line. Now, when we say we're finding the derivative, what does that mean? It means that we are finding the slope of the horizontal line. The horizontal line here, in this case, has no slope. If it has no slope, then the answer is just 0. Because see, the slope is 0. Slope is 0. Horizontal line has no slope. In other words, this implies the derivative is 0. I hope that makes sense now. Okay? You understand, Mishka? We good? Easy rule to remember. Okay? Take the power, multiply by the constant, take away 1 from the power. That's it. So always follow this rule. Take the constant, multiply by the power, and take away 1 from the power. That's it. And then simplify after that. Next question. Right, question 9. See how question 9 is written. We have f of x is equal to 1 over root x plus 3x squared. Now we can't differentiate this because this part over here, the first term is in radical form or in surd form. So we need to rewrite this in power form. So we say f of x is equal to 1 over, inside of outside, there's a 1 here, there's a 2 there, imaginary 2. We just don't write it. So that's x to the power half plus 3x squared. So now we're going to rewrite this. F of x is equal to x to the power. Remember, x to the power half. We need to write it in power form. So it's negative half. Okay. Plus 3x squared. Now it's written in power form because it's written in exponent form, power form, right? I just call it in loose terms, power form or exponent form. Now we can find the derivative. The derivative means the slope function. What is the slope of this line? So the derivative is -1. Now, what's the constant here? There is a constant which is 1, which we can't see. So now negative 1 times -1/2 is -1/2. X to the power -1/2, -1. You're always -1, no matter what, right? Plus 3 times 2 is 6. X to the power 2 minus 1. And then you can simplify. So we're getting -1/2, x to the power -3/2 plus 6x. Now we have a problem because this is negative power. So put it in positive power form. So if you put this in positive power form, you get -1. This whole thing goes to the denominator. If that entire thing goes to the denominator, it becomes 2x to the power +3/2 plus 6x. And that's my answer, the derivative of this. So what does the derivative mean? The slope, okay? The slope function. Are we good, guys? Enough? You understanding? We good?
Yes.
Excellent. Question 10. Now, how are we supposed to solve this? Remember to put it in power form. So to put this in power form, we're going to split up each one over x because we have a common LCD. So we're going to say y is equal to x to the power 4 over x minus 2x cubed over x plus x over x, correct? Now we carry on simplifying. We say y is equal to x cubed minus 2x squared plus 1. Now note that we have a constant here, and we know the derivative of a constant is 0. So we can say y prime, right? Now what is y prime? 3 times 1, which is 3x squared. We took away 1 from the power, minus 2 times 2 is 4. X, we took away 1 from the power. 2 minus 1 is 1. So I'm not putting the 1 there. X to the power 1, right? Anything to the power 1 is just x. So that's the reason why I'm not putting it there, right? That's 1 and another one. Anything to the power 0 is 1, okay? And what's the derivative of a constant? 0, okay? And you know why. Okay, because it's a horizontal line. And that's my answer. My answer is just 3x squared minus 4x. Right, that's the answer. True for the derivative of this function here. Next question, question 11. You only have one rule, put it in power form and then differentiate. If you can't put it in power form, then you can't differentiate, okay? So g of x is equal to square root of x times x squared. So square root of x is x to the power half and x squared is x squared. Now you are multiplying powers with same bases, so we need to go and add them up. So that becomes x to the power 2 plus half. 2 plus half, you can use a calculator, or 2 plus half, you know, is 2.5, which is 5 over 2. Right, that is g of x. Now, what is g prime x? Okay, the small symbol means prime, or g derivative x. G derivative of x is 5 over 2 times 1. So that's 5 over 2. X to the power. Take 5 over 2 minus 1. Okay, you're always minusing 1. You can see every time you have to minus 1. So what we're getting? 5 over 2. Where are we getting the 5 over 2 from? By multiplication. 1 times 5 over 2 is 5 over 2. 5 over 2 minus 1 is x to the power 3 over 2. Okay, sometimes this here can be written as 5 over 2. If you're going to put this in radical form or put it in surd form, you're going to say that's the square root of x cubed. So sometimes it's also written like this, okay? So, but you just need to leave your answer in positive exponent form. So this is good enough. Move on. Any questions, guys? Question 12. Mishka, you want to try this out? Y equals? Come on, guys. Try this. 5 x to the power. Come on, remember, we need to put it in power form. So how can x squared be written? We need to take it up. If you're going to take it up, it becomes negative exponent, okay? Minus, carry on. 2.
Then would you say 2x minus 3?
Yeah, to the power negative 3 plus 4. Right, now let's find y prime, the derivative. 5 times negative 2 is negative 10. X to the power, take away 1 from minus 2, you get negative 3. Okay? Minus 2 times minus 3 is positive 6. X to the power, take away 1 from the power, which is negative 4. That's it. And the derivative of constant is just 0. So no need to write 0 there, okay? I explained why the derivative of the constant is 0. Because a constant is just a line. It has no slope. That's why we can always ignore the constant when we're finding the derivative. Now, remember to write your answer in positive exponent form, which is negative 10 over x cubed plus 6 over x to the power 4. Excellent. Are we good, guys? Arnav, we good?
Yes.
Now the question is, how am I supposed to solve this? How am I supposed to solve this? Okay, this is similar to the problem that we had above by splitting. We have to split up. But the problem with the splitting up is that it has to be opened up on the numerator. So we got to open this fraction up on the numerator first. So if we expand that, let's expand this. 2x times x is 2x squared. 2x times minus 3 is minus 6x. 1 times x is plus 1x. And 1 times negative 3 is negative 3. Right? Divided by x. Now, we have to simplify this. So we got 2x squared minus 5x minus 3 over x. Okay, so now we can split up, which is 2x squared over x minus 5x over x minus 3 over x. Now see, put it in power form. So if you write this in power form, 2x squared divided by x, 1x cancels out, so you just left with 2x. X and x cancels out, so we left with minus 5. And this is minus 3. Put it in exponent form. So this denominator goes up, becomes negative 1. Now you can clearly see there's a constant here. So the derivative of that is 0. So I'm not going to write a 0 there. Well, I will write it now. So we're saying the derivative of 2x, what about 2x? Is 1 times 2 is 2, right? X to the power 1 minus 1, which is 0, plus 0 here. Minus 3 times minus 1 is plus 3. X to the power, take away 1 from the power, we get negative 1, which is negative 2. Now simplify. We just have 2 here, plus 3. X to the power negative 2 becomes positive exponent, which is x squared. That's it. And that's my answer. Now, I want to go over something very important. Note, we have y is equal to mx plus c. What do you think the slope of this line is? The slope is the derivative. The slope of this line is m. Okay, how you got m? Watch here. So I've got 1 times m is m, x to the power 0, derivative of constant is 0. So see, it works. The understanding should be there. Why are we finding the derivative? The derivative is to find the slope. So what's the answer? M. And you know m is the slope of the linear function. So what's another way to find slope? Y prime. That's it. Okay. I hope all these information is making sense to you. So I could have just asked you, what's the derivative of 2x minus 5? You can see the derivative is just 2 there because that's a linear function. 2x minus 5 is just 2. And the derivative of that obviously is going to be, because it's a different type of a function, right? It's not linear. This is rational. Let's continue. So that was example 13. Now, next notation. Remember what we just did now? We said, what are the different notations in differentiating? What are the notations? Notations in differentiation. Right? Or derivatives. Derivative notation. You can also call it derivatives notation. What are derivative notation? Well, we just learned one where we said, okay, f of x, let's just take this linear function here. If f of x is equal to mx plus c, then f prime x is just equal to m. That's one notation we learned, f prime x. Second one, f of x, not f of x, we use something called y, right? Or we can call it y equals mx plus c, y prime is m. Okay, so this is the first notation. Second notation, we use something called, if we have y equals mx plus c, right? So we say dy over dx. Differential change in y with respect to x. So you're differentiating x, that's what it means. You have a function y, you are differentiating x. So if you differentiate x, in other words, there is a m there next to x. So the answer is just m. So this is the next notation. Remember, it's the same thing as saying, you know, like when you have change in y over change in x, instead of saying change in y over change in x, we're saying dy over dx. So this is also the slope. Third notation that we use, we say derivatives. Derivative of x, and we put the function inside. The function inside that we put is mx plus c. Now make sure this is in power form always, and after you differentiate, then you can write down the answer. The answer is m. So these are the three different notations that we use. Okay, you can also call this ddx, right? This can also be represented as ddx of mx plus c, which is equals to m. So these are the three different notation. We hardly use ddx of mx plus c, so but these are the important ones. See the one, I'll just put an asterisk here. We hardly use this, but you see these types of questions. It means the derivative of the function. What is the derivative of mx plus c, which is m? These are the notations that we use. Right, so moving on to the next example, which is example number 14. See what the question says. Find dy dx. Now, when they say find dy dx, don't write y prime now. Write dy dx after you simplify, okay? So here, we want to find dy dx. First, question number one, is my function in power form? Yes, it is. There's no radicals, there's no fractions, right? So this is already in power form, right? Because it's in power form, we can find dy dx straight away. Right, so what is dy dx? 3 times 4 is 12, x squared, plus, remember this is linear, 5x minus 7 is linear, so the derivative of a linear function or the slope of the linear function is just 5. That's it. See how easy it is when you identify stuff. Right, that's question number 14. Any questions, guys? Ms. Bishop, any questions? Are we good so far? Do you have any questions, guys? Let's see who's on. No questions?
No, sir.
Right, excellent. I hope you guys are understanding. Right, it's very simple. Remember, this calculus topic is a very big section in math paper 1. It's almost like 30 to, it's almost about 30%. Right, so let's find dy dx here. Dy dx. Right, so dy dx, take the power, multiply by the constant. So 2 times 4 is 8 x cubed. Minus 3 times 2 is minus 6. Take away 1 from the power, so minus 6x. And see what you got here. That is linear. So what is the slope of the linear function? 6. mx plus b, mx plus c. This is written in the form mx plus c. Okay, so that's my answer, 6. That's it. There will be some confusing ones, so watch. Right, so we have y equals pi x squared plus 2 pi x minus root 3. Is this in power form? So how do we notice whether it's in power form or not? Look at the variables. That's in power form. Okay, that's in power form. Problem solved. So we can say dy dx equals pi times 2 is 2 pi. Take away 1 from the power, so 2 pi x. And look at this. This is written in the form mx plus c. That is a constant. Root 3, square root of 3 is a constant. There is no variable there. That is just a constant. So the derivative of the constant is 0. Right, so mx plus c, you can see this is already in c. This is your mx plus c. So you just need to write down the value of m here, plus 2 pi. That's your answer. But if you want to use a rule, see, if you want to use a rule here, you're going to say 1 times 2 pi, 1 times 2 pi, x to the power 1 minus 1. And that is x to the power 0, which is 1. What answer you get? You still get 2 pi. Okay? And derivative of negative root 3 is 0. So there, you still got 2 pi, even using the rule. What rule is that? The derivative rule, or we call it the power rule. Where is it? Yeah. Just called the power rule. Okay, right, excellent. So it's not so bad. So far, so good. Let's look at question 17. Right, question 17 is similar to what we have done before. Not difficult at all. We need to put it in power form first. Rule number 1, put it in power form. The first one is in power form. The others are in rational form. So put it in power form. So y is equal to x to the power 4 plus 2 x to the power negative 1 minus 3 x to the power negative 2. Okay, we just bring all the variables from down up. Bring the variables, only variables, don't bring numbers up. Okay, so let me change this a bit, right? Because I know what you're going to do. You're going to end up bringing numbers up. So what if I change this to 2 over 3x? So you only need to bring the variable up. Do not bring the number up, then you're going to be in problems, right? So you need to write this as 2 over 3. I changed this a bit, all right? So that's your question. Let me just say this is a 3. Now, let's solve this. So y prime, don't say y prime, we want to find dy dx. So write dy dx, change in y over change in x. That's what it means. So 4 times 1 is 4, x to the power 3, minus 1 times 2/3 is minus 2/3, x to the power, take away 1 from negative 1, you get negative 2. It's like you have a point which is negative 1, right? Negative 1 is here. You're always going 1 to the left. Always go left, right? So negative 1 is negative 2. Okay? So let's take that out. You know what to do. Or you are there, the function is high. When you differentiate, the function goes low. So it must be smaller. Then the next one is minus 2 times minus 3 is plus 6. X to the power negative 2, negative 1 is negative 3. Now write it in positive exponent form. So that's 4x cubed. Remember, the negative 2 needs to go back down. X squared plus 6 over x to the power negative 3 needs to go down, which is that. And what does this represent? The slope function of this. Okay? Question 18. Oh, okay, I'll give you an example. Like, Arnav, you want to try this out? Come on, guys, it's an interactive lesson. You can talk. Right, so we can see this is not in power form and this is not in power form, right? So we can say y is equal to 2x cubed, right? What about the next one?
It will be
Minus 5.
minus 5 and x to the negative 4.
Right, good. Plus 1 over 2. Let's leave that as it is. Yeah, Mishka, you can try this out. X to the power. This is a radical 5 over inside over outside.
5/2.
5 over 2. Good. Now we need to put it in power form, right? So bring everything up. Plus half x to the power negative 5 over 2. Right, great. So now we can say dy dx is now equals to, remember this is already in power form, so apply the power rule. So this is in power form. That's it, guys. All you need to do is power form, no matter what equation you have. Right, so 3 times 2 is 6x squared. Minus 5 times minus 4 is plus 20. X to the power negative 5 plus, what's half times negative 5 over 2? Half times negative 5 over 2 is, I don't know why I put a plus there, should be a minus. Positive half times negative 5 over 2 is negative 5 over 4. Half times 5 over 2, you can see 2 times 2 is 4. 1 times minus 5 is minus 5. X to the power, remember you got minus 5 over 2 and you're going to subtract 1. So you'll get minus 7 over 2. Right, now continue with this. 6x squared plus 20 over x to the power 5 minus 5 over 4 x to the power. Remember, we're putting this in positive exponent. It's a negative exponent, put it back down. 7 over 2. If you want to write it in a better form, like the original question, how it was in radicals, you can do that as well. So this is, remember, the inside will be x to the power 7 and the outside will be 2. So you can also write it like this, 6x squared plus 20 over x to the power 5, but it's not required. 4 square root of x to the power 7. Okay. And so far it's good. Let's continue. Question 19. So we need to go right up to question number 40. We will go fast because I think by now you should have got the hang of it, but you can see the derivatives might get a little bit more challenging. Right, so we have some values here. Let me change this a bit, right? So let's say 4 over 5 here. Yeah, so you can say y equals, simplify first, y equals x to the power negative 3 plus 4 over 5. Remember, this is x to the power half. Please don't skip steps because you are bound to make mistakes. Don't try to skip steps. Just go in order, right? So let's see, y equals x to the power negative 3 plus 4/5 x to the power negative half plus 5x. Now remember 5x, we identify 5x as linear, so we know the slope is 5. So we can just write down 5 there. Remember what we're finding, dy dx, which is negative 3 times 1, negative 3, x to the power negative 4. Now this is where the trick is. 4 over 5 times negative half. Remember, we're taking 4 over 5 times negative half. Simplify. So you can see clearly the 4 and the 2 cancels out 2 times. So it's negative 2/5, right? X to the power negative 3 over 2. We took away 1 from the power. Minus half minus 1 is minus 1.5. Okay. So we're getting negative 3 over, put it in positive exponent. We're going to have a negative exponent here and a negative exponent there, as you can see. 1, 2. So that's x to the power 4 minus 2/5 x to the power 3 over 2 plus 5. That's my answer. That was question 19. See question 20. Misha, you want to try this out? 3.
Would it be 3 and then you take x to the power for half?
Yeah. Minus
And then
2
minus 2 and then
over
x 1 over 3
correct.
plus 7.
Right. Write it in power form. 3x to the
So
power half minus 2
x to the minus 1 over 3
plus
plus
7. Find the derivative of this. 3 times half.
Okay, wait.
3 over 2. Yeah, use a calculator, you can. 3 times half is 3 over 2.
Yes, and then
X to the power half minus 1. Negative half.
yes, and then would you say
Minus 2 times minus, yeah. Minus 2 times negative 1 over 3. Plus 2 over 3, right?
yeah,
And then x to the power negative 1/3 negative 1 will be negative 4 over 3. Yeah, plus 7. And then we're going to write this in positive exponent form. So we got 3 over 2 x to the power half. That's it. Plus 2 over 3. Bring this down as well. 4 over 3 plus 7. Stop here. You don't need to write it in a radical form unless the question asks you for, right? Because you know this is inside over outside. Excellent. What question did we just do now? Question 20, yeah, 21. Right, so as you can see, you have the fourth root of x. So y is equal to x to the power 1 over 4. Right, you can see, don't worry about these numbers, right? Pi cubed is just a number, so focus on the variable. There is no variable here, so the derivative of that will be, you know what that will be, right? So plus pi cubed x minus e squared. I'm finding the derivative, so dy dx will now be quarter times 1, which is quarter, x to the power, quarter minus 1 is minus 3/4, 1 times pi cubed, or you can think of this as written in the form mx plus c. There's your mx plus c, right? But anyways, let us apply the power rule. 1 times pi cubed is pi cubed. Take away 1 from the power, so that's x to the power 0, and derivative of constant is plus 0. Simplify. 1 over 4 x to the power 3/4 plus pi cubed. That's it. All right, guys. Easy. Let's look at question number 22. I will leave some of them out because I can see some repeats here. Okay. So again, this is similar to the previous form. So we have y equals, yes, Arnav, do you like to solve this? 3 over
3 over x to the power of 2 over 5.
right, plus 2x minus root 2. What can you tell me about root 2? You say?
It can be changed to
No, it's a constant. You're only changing
oh,
variables. Yeah. Be careful. You're only focusing on the x, right? You're only focusing on the variable, not it can be changed. It can't be changed. Root 2 remains root 2. Right, so now let's see. Now we can write this thing down. Y equals 3x to the power 2/5. Remember with the negative because we're bringing the variables up. Right, take it up. Plus 2x minus root 2. Remember we said root 2 is a constant, so the derivative of the constant is 0. And what's the derivative of 2x? That's a linear function, so that is just 2, right? And all we need to find is a derivative of this here, 3 times negative 2/5. 3 times negative 2/5 is 3 times negative 2, which is negative 6 over 5.
5.
X to the power negative 2 over 5 minus 1. Don't minus 1. Try to minus 5 over 5. 5 over 5. So you get negative 7 over 5. That's how you can do mental math quick. Right, I didn't minus 1, I minus 5 over 5. So minus 2 minus 5 is minus 7 over 5, right? So minus 6 over 5, x to power 7 over 5 plus 2. And that's your answer, okay? As I said, I would skip a few, let me see, 22, right? So 23 we will skip. 24. We'll skip 24 as well. 25 we have done. Right, so we can skip those. You can do it as homework, right? Right, let's look at the next types of derivatives with the dx, because you got to get used to the notation, all right, as I said. So let's focus on question number 26. Right, so what you are differentiating x as a variable. And see what we have inside here. We have a big function inside here. So you got to simplify the function. You only drop the dx after you differentiate. So we can't differentiate now because we need to open up everything. So this is going to open up into a cubic polynomial because x times x squared is x cubed. X times minus 3 is minus 3x squared. X times 2 is plus 2x, right? So we open it up like this, 1, 2, 3, right? And that one, that one, that one. So you can end up with 6 terms. So we got plus x squared minus 3x plus 2, right? So those are the terms that I have. And now I will still need to simplify, then differentiate. After you simplify, the last part is to differentiate. Right, so what we have here is only 1x cubed. We can see we have x squared term here and there. So minus 3x squared plus x squared is minus 2x squared, right? And we have a 2x here and a 3x there, right? So plus 2x minus x plus 2 minus 3x is negative x. And we just left with a single constant. So now you can identify this as a linear function. The slope of the linear function is -1, or the gradient is -1. So let's differentiate this. 3 times 1 is 3. Take away 1 from the power, so 3x squared. -2 times 2 is -4. Take away 1 from the power, so x. And then just -1. Are we good, guys? That's easy. Right, because remember, the slope of the linear function is -1. This is in the form mx plus c. Next question. Question 27. Right, so this is written in a similar form, all right, as you can see, but now we have 3 brackets. So how do we open up 3 brackets? So dx, open up the last two, leave the first one as it is. So 2x minus 5, okay? And if you open up this, you're going to get 3x times x, which is 3x squared. 3x times minus 2 is minus 6x. What I'm doing, collecting all the x terms. That's minus 6x plus 1x. So that's plus 5x. And 1 times minus 2. Yep, like that. Right. So I've already collected 3x times minus 2 is minus 6x. Plus 1x is minus 5x, not plus 5x, minus 5x, because that is minus 6 plus 1, minus 6x plus 1x minus 5x, and 1 times minus 2 is minus 2. So I've got it in the first type of form. So dx, if you open up everything, 2x times 3x squared is 6x cubed, 2x times minus 5x is minus 10x squared, 2x times minus 2 is minus 4x. Then we have minus 5 times 3x squared minus 15x squared. Then we have minus 5 times minus 5, which is 25x. We have minus 5 times minus 2, which is plus 10. Right. And now we are ready to differentiate. Please use square brackets in this notation here. So now when you say dx, 6x cubed, right? And then we got 10x squared minus 15x squared. That's going to give us minus 25x squared. Then we have minus 4x plus 25x. So that's plus 21x plus 10. We can clearly notice that the last two terms are linear and the slope is 21. So now we are ready to differentiate. When you're differentiating now, you can drop the dx. You only drop the dx after you differentiate. So 3 times 6 is 18x squared. I took away 1 from the power. 3 times 6 is 18. Take away 1 from the power. Minus 25 times 2 is minus 50. Take away 1 from the power. It's just x plus 21 because that is linear. This is linear form. And the slope of the linear is 21. Okay. So that was number 27. Right, so question 28 is a little bit much more easier, right? So we have dx, which is equal to root x into x squared minus 2. So this is not in power form. So put it in power form. So that's dx. Mishka, you want to try this out? Or anyone else, guys, if you want to try out a question, just put your microphone on and say, okay, let me try this out. Okay. Yeah, Mishka, you can try this out. Remember to just to put it in power form. That's it. The root x we're going to change.
So would you change it to x to the power of a half?
Right. And then x
And
squared minus 2. Now multiply it out.
so then would you say x? It would just be x, right, for the first one?
Now you're multiplying it out inside like this. So dx, x to the power half times x squared is x to the power half plus 2. What's half plus 2? 5 over 2. Okay.
Okay.
And then x to the power half times negative 2 is negative 2 x to the power half. Right, this is just algebra. Now we have it in power form. We differentiate and drop the dx. So 5 over 2 times 1 is 5 over 2 x to the power. Take away 1 from the power. That's 2.5. You get 1.5. 1.5 is 3 over 2. Minus, make sure don't write 1.5 and 2.5s and stuff. Don't use decimal points, use fractions. Minus 2 times half is minus 1. X to the power negative half. Now we still got to simplify this. That's just 5 over 2. X to the power 3 over 2 is fine. This one needs to go to the denominator. So minus 1 over x to the power half. That's it. You understood that, Mishka?
Yes. So when you're doing the top one, like the fraction, you just minus a 1 all the time, right?
Always.
Okay.
We are applying the rule. The derivative is always minus 1 from the power. Whenever you differentiate, you're always minus 1 from the power. Don't ever forget that. And that's the rule that we started off with. See? N minus 1, power minus 1, always. So in order to do power minus 1, you have to put it in power form. All right, so question 29, we're going to skip that as well because, okay, let's just do it. Let's do question 30. Okay, so I'm skipping this one because we have done problems similar to that. Just split and solve. Let's do this one here. And then from 31 onwards is exciting there. Okay, so even this one is split up, but so first we need to write it in this form here. So this is x plus x to the power half over x to the power half. Now you can split up and solve. You say f of x is now equals to x over x to the power half plus x to the power half over x to the power half. Right. Now, what happens when you divide the exponents? You need to subtract the powers. So that's x to the power 1 minus half plus x to the power half divided by x to the power half is just x to the power 0, right? Half minus half. We can just cancel them out and make it 1, right? You can just cancel them out. That value is just 1. But now we got a problem here because 1 minus half is half. So x to the power half plus 1. You know the derivative of a constant is 0. So now we're going back to the original notation because this is f of x. So now we can write f prime x is now equals to half times 1 is half x to the power. Take away 1 from the power, which is negative half. And the derivative of constant is 0. Take this negative power down and make it positive power. So 1 over 2 x to the power half. Better, you can write it in root form. X to the power half is root x. And that is your final answer. Okay, make sense? Arnav, we good? You understood that?
Yes.
Right. Excellent, guys. Now, what happens? You know how to split up. Excellent. Because you can see you have single terms. When you have many term over single term, each of those terms can be split up over that single term, right? So split and simplify. So when you have many over one term, then we can split and then simplify, right? Now, what happens when we have many over many terms? Then you can't split and simplify. You have to use some other techniques. So the technique is called factorization, right? So you got to factorize and then solve. So let's have a look at that example there, which is number 31. Now, this is a case where we can't split up this over this, right? So we gotta factorize and solve. So it's very simple. F of x, which is equals to x squared minus 16. That is difference of two squares. It's like this formula here, a squared minus b squared. What's a squared minus b squared? A plus b, a minus b. That's what it is. That's the form that we have here. So to factorize this, x squared minus 16 is x plus 4, x minus 4, divided by x minus 4. And guess what? We cancel x minus 4 out. And then we say, okay, f of x is equal to x plus 4. That's my answer. But now, what's the derivative of x plus 4? Yes or no? What's the derivative of x plus 4? Remember, this is linear. What's the derivative? M. What's the slope here? This is linear, right? Okay, let's apply the power rule. 1 times 1 is 1. X to the power 0, derivative of constant is 0. So what are you getting? 1. So remember, the derivative of the linear function is just the slope. Right, so that answer was 1. Look at another problem. With factorization, okay? Now these are problems involving factorization because we have many terms over many terms. So see here, we have 2x squared plus 3x minus 5 over 2x plus 5. So I'm going to factorize this to cancel the 2x plus 5 with the 2x plus 5 on top. So you can use a cheat method. Right, so I am going to write 2x plus 5 here, right? And I know I have 2x plus 5 at the bottom. So what's the balance of the factors I'm left with? 2x times x and 5 times minus 1 will give me that, right? So let's see if it actually works out. 2x times minus 1 is minus 2x plus 5x is plus 3x. So the sum works out. We know we are getting 3x. But if you're looking for the factors on the calculator, you go to mode 5 and 3. Use the quadratic function, which is 3. And enter these values, 2, 3, minus 5. A value is 2, B value is 3, and C value is negative 5. That will help you factorize. So what we're getting? 1. So you take this 1 and bring it over. Remember, I'm getting... So what you are doing is you're saying 2x squared plus 3x minus 5, right? So you're trying to factor this out. Remember, you're actually solving an equation, but we are not solving an equation. We want it in factorized form. So you're getting x1, which is equals to... let's go back. X1 is equal to 1, and you're getting x2, which is equals to x2, you getting... I didn't check x2. X2 was minus 5 over 2, all right? So you're going to bring the 1 over, you're going to get x minus 1, right, as a factor. And you're going to bring the minus 5 over, you're going to get x plus 5, right? Now, before you bring the minus 5 over, you need to cross multiply the 2 because you have a fraction. So 2x, and then bring the minus 5 over. So 2x plus 5, there's it here. Okay, so this is just quick recap of grade 11 stuff, right? So how to use your calculator to factorize quadratic and cubic function. Even there's a method to factorize cubic function, which we will learn in calculus, okay? Right, so we have all this. We can clearly see that 2x plus 5 and 2x plus 5 cancels out. Now I have f of x, which is equals to x minus 1. But now x minus 1 is already linear, so the derivative is just 1, which is the slope. Let's call it gradient. Gradient or slope, same thing. Right, so the gradient, f prime means you're finding the gradient. Right, so nice. You can see the problems are all different. Now let's look at question 33. Because we're going into factorization now. So all your knowledge of factorization comes in. Now x cubed minus 8. Now, if you don't know how to factorize, how are you going to solve x cubed minus 8? So if you remember, cubic factorization, especially with these ones, so you're going to say a cubed minus b cubed is a minus b into square the a, you get a squared. Product of these two, the opposite signs, so plus ab, and you square the negative b, you get plus b squared. Okay? Now, what if there's a plus here? If there's a plus here, then this will also become plus, and only the middle sign, only that will become negative there. Right? So what we have here is negative, so that's going to become x minus, what's the cube root of 8? 2. X squared is x squared, minus 2 squared is plus 4, and the middle term is 2 times x, right, which is 2x with opposite sign, divided by x minus 2. Right, now we can see the x minus 2 and the x minus 2 cancels out. So this function actually simplifies to be x squared plus 2x plus 4. We can clearly see that this is linear. We only need to find the derivative of the first, right? And obviously the second. So derivative of x squared is 1 times 2, which is 2x. Take away 1 from the power, so it's just 2x and plus 2, because this is linear. This is the gradient. Okay. If you're going to try and use the power rule, no problem. The power form, you're going to say, okay, so 2 times 1 is 2, x to the power 2 minus 1, plus 1 times 2 is 2, x to the power 1 minus 1. And you already know that the derivative of constant is 0. So there, you get the same answer, 2x plus 2, because that's x to the power 1 and that's x to the power 0. So you get the same thing, okay? It's just quicker to realize that that's a linear function, and the gradient of the linear function is just m, okay? The number next to x, right? So that's it. Now, what if you didn't know how to factorize x cubed minus 8? How are you going to get all this? So I'm just going to show you on the calculator. If you have your calculator in front of you, try it out, right? Calculator, right? How to do x cubed minus 8 equals 0. Now remember, the cubic function is in this form. Y is equal to ax cubed plus bx squared plus cx plus d. Now if you're comparing here, we have an a value which is 1. So a is equal to 1. There is no x squared term here, so b is 0. And there is no x term here, so c is 0. Aha, there is a d term which is negative 8. Okay? So the value of d is negative 8. Right, guys. So far so good. So now what we are doing is we're going to put all this into the calculator and see what answers we get. So we're going to get x equals or x equals. Remember, we have to get 3 answers, all right? So let's see. You go to mode 5 and select the cubic function. Option number 4. Maybe your calculator might have option number 5. So you select the cubic function and enter these values. 1, 0, 0, negative 8. And I'm getting an answer of 2, right? And look at the other numbers I'm getting. It's like complex. So I need to leave that out. So I only have one answer. Okay, so x cubed minus 8, I know if I bring the 2 over, I will get x minus 2. And what about the other terms? The other terms, be careful. How are we going to get the other terms, all right? So to get the other terms, you need to rewrite this cubic function. Okay, to get the other terms, you're going to say this is x times what is x cubed? X squared, right? Minus 2 times what is minus 8? Minus 4, okay? It has to be plus 4 at the end. But now we got a problem with the middle term here, okay? The middle term over here, plus kx. I'm going to put a k here, right? Because I have a problem with the middle term. How am I going to get the middle term? Now be careful, see what I'm doing. You take the product of these two, okay? You take the product of the coefficients of the inner terms, watch here. You see, and it works for every single cubic function. You take minus 2 times 1, see? Minus 2 times 1 is minus 2. Product and opposite sign. Remember, there's a 1 here. Product and opposite sign. So minus 2 times 1 is minus 2. What's the opposite sign of minus 2? 2. And you add it to the x squared term here. So what was the value of b? 0. You add it to 0. So what I'm doing is I'm taking minus 2. Minus 2 times, okay, let's just say minus 2 times 1x squared, right? And you take the opposite sign here, put a negative. And you add it to the x squared term in your cubic function, which is 0x squared. So what's my total result? 2x squared, right? Because this is negative 2x squared plus 0x squared is, and remember there's a negative there. So negative, negative, positive. Why did I put an x here? Times, put a dot, right? That's easier. That's why I said don't work with the x squared. So you only take this value here, the coefficient, which is 2. So now we're going to erase the k off and put a 2 there. And it works for every single cubic factorization. So did we have x squared plus 2x plus 4? Right, so I'm just going to put this in so you can just watch that again. Right, so but remember, we already had an answer. I'm just showing you how to use a calculator to factorize x cubed minus 8 if you forgot those rules. Now you can factorize every single cubic function like this onto the calculator. Look at question number 34. Right, next question, question number 34. Find f prime x if f of x is equal to kx cubed plus mx plus b. And they're telling us that k, m, and b are constants. Okay, so that's a constant, that's a constant, and that's a constant. So great, this is already linear. So I can find f prime x. Easy, differentiate x, right? So 3 times k is 3k. I take away 1 from the power, so that's x squared. And the derivative of mx plus b, the slope is just m. Problem solved. So easy. Right. Look at question number 35. Now we're coming across all different notations, okay? Find dy dx if y equals ax squared plus b over x. Now we have a problem because this is in power form and this is in rational form. So put everything in power form. So y is equal to ax squared plus b x to the power negative 1 because I just brought this x up. Right. Now we can find dy dx because that's already in power form. Arnav, you want to try this out? Mishka, you want to try this out?
I'm not too sure like how to do this.
Just multiply this out. Just multiply like normal. 2 times a is 2a. And
Oh,
then take
like
away, yeah, power rule.
okay, then it's x minus, I mean just x, yeah.
X, right? And b
And then
times minus 1 is minus b.
it'll be x minus 2.
Yeah, perfect. And then simplify this. 2ax minus b over x
X squared.
squared. Yeah, that's it.
Oh,
Simple.
okay. That's not that bad.
Yeah, it's quite easy. Just remember, the rest of them are all constant. You're only differentiating x. Focus on the x variable. The rest of them is just numbers or constants. All right, question number 36. Okay, so this here looks like a physics equation here. Yeah, with some gravitational acceleration, velocity, and initial height. Okay, anyways, don't focus on that. Just think of that as variables. And now what we are differentiating? We are differentiating. See, I changed the variable now. We're differentiating t. So t is your variable. Focus on the t, right? So let's differentiate this. Anyone? Kiara, you want to try this out? Arnav? Guys, it's not hard. Just focus on the t. The rest of them are just all constants. Mishka, you go one more time. Take half
Okay.
g times 2.
So you just say half times 2, is that it?
Yeah, no, half g times 2. So half times 2 is 1. So it's just g, right?
Yeah.
Okay, let me do it long method. Half g times 2. And take away 1 from the powers. So t to the power 2 minus 1. Plus v naught t is just 1 times v naught. T to the power 1 minus 1. And plus 0 because derivative of constant.
Okay,
So
yeah.
half times 2 is 1. So it's just g. We just simplify now. gt
Um,
plus v naught because that's t to the power 0 is 1. Right?
yeah.
Right, excellent. That's it. That's your answer. The derivative is with respect to t. T is your variable. There is no x variable here now. Remember that before the derivative with x, the variable is x. See, the variable is x here. Now you keep on just changing the variable. That's it. It's the same thing. 37. Right, so remember over here, the variable is r. I shouldn't have wrote pi as a constant. You already know that. The variable is r, right? So we focus on the r variable, Great. The rest of them are just all constant. Yeah, you can try this out, Arnav. F prime r. Yeah, we can differentiate because this is already in power form.
So basically, it's
2 times pi.
2 pi
2 pi.
r
Good. 2 pi r plus
plus 2 pi
r to the power 0
0.
because that's to the
Yeah.
power 1. Good. Right, so now r to the power 0, you can simplify now. If you're going to write r to the power 0, you need to do the next step, simplify. 2 pi r plus 2 pi. Okay, you can factorize this, simplify. You can say take out 2 pi as a common factor, and that's just r plus 1. Right, we're going to use this at a later stage when you're trying to find maximization and minimization. Let's look at number 38. Right, so now again, we have r as a variable because see, you want to find s prime r is your variable. But now we have that in power form and this is in a rational form. Mishka, you can try this out.
So would it
4
be,
pi r squared.
yeah, and then plus CR to the minus 1.
Right, good. Find s prime r now.
It would be 8 pi
8 pi, good. 8 pi r.
plus CR to the minus 2.
Wait, 1 second. Let's multiply those two out first. I don't think you multiplied them out. Was minus 1 times c.
It's minus C.
Multiply, then subtract the power. Okay.
Okay.
Minus c r to the power negative 2. Now we need to write the negative 2 in terms of positive exponents. So 8 pi r minus c over r squared. Okay.
Yeah.
Right, great. That's your answer. And let's look at, we have 2 more questions, guys. Just bear with me. Because these are all the different types of questions that you can expect in your exams, right? And we did a lot. I just skipped a few because I need you to understand everything properly. See what they want. Find dy dx if x cubed minus 5x squared minus yx squared plus 6x plus 4y is equal to 0. Whoa, what are we going to do here? Right, so we want to find dy dx. We want to differentiate x, okay? So obviously I need to throw all the x's onto the other side. So let's keep the y's here only. We have to solve for y. So we're going to say, all right, so minus y x squared plus 4y. Let me keep this on the side and throw everything else over. So that's negative x cubed plus 5x squared. What else I have? Plus 6x, right? Goes on to the other side, becomes minus 6x. So what we have here, let me see. Minus x cubed plus 5x squared minus 6x. All right, that's great. But now we have a negative x cubed onto the other side. So let's do this. Let's multiply everything by a negative. So we have yx squared minus 4y is equal to x cubed minus 5x squared plus 6x. Okay, that's much better because we multiply by negative. All right, we multiply by negative. We're trying to solve for y, all right? So to solve for y, we have two y's here. So let's take out y as a common factor. And we're left with x squared minus 4. And what's on this side? We can take out x as a common factor here. So we got x into x squared minus 5x, x into x squared minus 5x plus 6, right? I think there was something wrong with this question. It shouldn't be a x squared here, sorry. Let me just take out the x squared from here. Yeah, there shouldn't be a x squared. There's a problem with this question, yeah. Yeah, no x squared, just x. Yeah, they won't give you something so difficult. All right, so I took the okay, let's try to solve for y. So we solve for y first. Y is equal to x into, remember we can factorize this as well. So because I took the x squared out, we can't really factorize here. So we have y into x minus 4. We can factorize this, correct? So that's x minus 6x plus 1. Is that correct? Minus 6. No. Then I was supposed to get minus 6 here as well. X minus 6, x plus 1. That's going to give me minus 5x. It should be minus 6 here. Why did this question go off? Minus 6 here.
-3, -2, I think.
Yeah, minus 3, minus 2. Yeah. Minus 3, minus 2. Yeah, okay. That's perfect. Plus 6. Minus 3, minus 2. Yeah, that's right. Minus 3, minus 2. Then there's a problem here then. Yeah, there's a problem with this question, man. It's supposed to work out. I'm going to change it. Change the 4 into a 3. Yeah. 3y minus 3y minus 3. Yeah, because it's supposed to cancel out, right? The idea is to collect all the y's on one side and all the x's on the other side, and then factorize and solve. So if we solve for y, we got x into x minus 3 into x minus 2 over x minus 3. Now we can see x minus 3 cancels out. Guys, I just changed this question here, right? So I put 3y because the 4 wasn't working out. Now we say y is equal to x into x minus 2. That's what we have so far. But remember, x into x minus 2, we can't differentiate this because we need to put it in power form. So we need to open them up. Right, so we got y is equal to x squared minus 2x. Now we can find dy dx, okay? That's why this problem was complicated. Now to find dy dx, 2 times x, remember, 2 times 1 is 2, product, and then subtract. 2x minus 2. 1 times 2 is 2, x to the power 0. So that's it. That's my answer. Okay, sorry about that. That question I just messed up. Okay, and this should be fine. Yeah, so we found dy dx, which is 2x minus 2. Perfect. Let's look at the last question. Right, so the last question is, if y equals square root of x plus 1 over 3x and x equals t cubed, determine dy dt. We don't want to find dy dx, we want to find dy dt. So what is y? Y is all this. And now we know x is equal to t cubed. So take t cubed and put it in the place of x. So we say y is equal to square root of t cubed. I'm replacing the x with t, right? Because they're telling us that it's like simultaneous plus 1 over 3 t cubed. Now we have a problem because I need to write it in power form. That second part is in power form. The first term is not. So y is equal to t to the power 3 over 2 plus 1 over 3 t cubed. So what we have now is dy dt. Now we can find dy dt, right? There's a 1 in the front, so 1 times 3 over 2 is 3 over 2. T to the power, that's 3 over 2, 1.5 minus 1, right? So it's half. 1/3 times 3 is 1 t squared, 1 times t squared. Now we want to find the value of this when t is 1. So if t is equal to 1, we're just finding this, right? So if t is equal to 1, we're getting dy dt is equal to 3 over 2, 1 to the power half, which is just 1, plus 1 times 1 squared. Right, so that just 3 over 2 plus 1, which is just 5 over 2. Obviously, the value will change if the value of t is equal to 2 and so on. All right, guys, any questions?